What are the types of the complete graph? The first type of the graph is the simple graph. Simple graph means what? When there is a no loop and no parallel edges are exist in the graph, then that graph is called as a simple graph. So there are some examples are given here of the simple graph. The graph G1, just like a triangle. Then graph G2 is also a simple graph. Graph G3 is also a simple graph. So this type of a graphs without loop and without parallel edges is called as a simple graph. It's a very simple definition of the simple graph. No loop, no parallel edges. Right? Then the second type of the graph is the regular graph. So when we can say that the graph is a regular graph, so a graph in which the degree of each and every vertex is the same. Whatever the number of vertices, but the degree of each and every vertex is the same here. So for example, these are some examples are given here of the regular graph. Regular graph, that means here in this first example, this is a 5 vertices graph in which the degree of each and every vertex is equal to 2. That means degree of this vertex is equal to 2. Degree of this vertex is also 2, 2, 2. So each and every vertex has a degree 2. So that's why this graph is called as a 2 regular graph. Similarly, in the second example or in the second graph, the degree of each and every vertex is 3. So that's why this graph is called as a 3 regular graph. Similarly, in the another example, there are the 4 vertices graph again, but the degree of each vertex is what? 4. In the last graph, last example, the degree of each vertex is 4 here. 1, 2, 3, 4. So every vertex has a degree 4. So that's why this graph is called as a 4 regular graph. Right? And the third type we discussed, the last type we discussed in the last lecture, that is a complete graph. There are after that also there are some types of the graphs out there, but this is the third type we discussed in the last lecture, complete graph. So when we can say that a complete graph is must be a simple graph. See, a simple graph is said to be a complete when if every pair of vertices is adjacent. Now already we discussed what is meant by the adjacent. Adjacent means what? If the two vertices are having an edge between the two vertices, then these two vertices are said to be adjacent. So the first thing, the graph must be a simple graph, and the second thing is that every pair of vertices should be adjacent. मतलब हर एक पेयर के बीच में edge होनी चाहिए. Okay, between every pair there should be an edge. Then that graph is called as a complete graph, and that complete graph is always denoted by kn, where n is the number of vertices. मतलब n vertices का graph रहेगा, complete graph रहेगा. So that will be denoted by the kn. Okay. This is the complete definition of the complete graph. So these are the some examples of the complete graph. So the first example, someone's mic is unmute. Please mute your mic. Everyone, please mute your mic. This is a complete graph with the one vertex only, K1. That first one. It is a complete graph with the one vertex only. Okay. So one vertex means only one vertex is there. So we cannot draw the any another edge to this one. We can draw the edge, but whose both endpoints should be connected to the vertex, and then it will be a loop. So then we cannot say it is a simple graph. So the graph, complete graph must be a simple graph. So there is no edge in the one vertex complete graph. So it will be denoted by K1. The second example, K2. K2 means complete graph with the two vertices. So there are the two vertices and there must be only one edge between the two vertices. Similarly, this is a complete graph with the three vertices. Okay, just like a triangle, and between every pair, that means suppose if I'll give the name to this vertices, then this is a vertex A, B and C. So there is an edge between A to B, A to C, then B to A, B to C also, and then C to A, C to B also. So between every pair there is an edge. So it is a complete graph with the three vertices and no loop and no parallel edge. That means it is a simple graph also. Then the next one, K4. So there are the four vertices, and suppose if I will say here U, V, W and Z. U, V, W, Z are the vertices of this K4. So U is adjacent with the vertex Z, W and V also. V is adjacent with U, Z and W also. W is also adjacent with U, V and Z also, and Z is also adjacent with U, V and W. So it is a complete graph with the 4 vertices. Similarly, this is a complete graph with the 5 vertices and complete graph with the 6 vertices. So like that, we have the complete graph. Okay. Now, there are the some notes related with the complete graph. The first note. See, what is the first note on the complete graph? So in the complete graph, every complete graph is a regular graph, but converse need not be true. मतलब every complete graph is a regular graph, but converse need not be true. Why we can say it is a complete graph with a is a regular graph? Because if you observe, see, if you observe every graph, every complete graph, now all these are the complete graph, K1, K2, K3, K4, K5, K6. So like that you can draw the K7, K8, K9 and so on. Okay. So here we have taken some examples. So if you have to observe the K1, now there is only one vertex and degree of this vertex is 0. So we can say it is a regular graph. K2, what is the degree of every vertex of K2? So degree of this vertex is 1 and the another vertex is also 1. So that's why it is also called as a regular graph, one regular graph. In K3, degree of each vertex is equal to how much? 2, 2, 2. So it is called as a 2 regular graph also. Then degree of each vertex of K4, complete graph with the 4 vertices. So degree of each vertex is 3. Degree of each vertex of K5 is 4. K6 is 5. Okay. So every complete graph is a regular graph because degree of each vertex is same. So that's why we can make a statement, every complete graph is a regular but converse need not be true. मतलब इसका converse मतलब रेगुलर ग्राफ कंप्लीट हो ऐसा जरूरी नहीं है, बट कंप्लीट ग्राफ इज ऑलवेज अ रेगुलर ग्राफ. इसके इसमें एक एग्जांपल बता दो आपको मैं. इफ यू हैव टू टेक दिस एग्जांपल, this one, two regular graph. So it is a two regular graph, that means regular graph, but is it a complete graph? No, because every pair is not adjacent. It is simple, but every pair is not adjacent. मतलब ये दो vertices के बीच में एज नहीं है, ये दो vertices के बीच में एज नहीं है. So that's why it is not a complete. It is a regular but not complete. Okay, so that means we can say that every complete graph is a regular but converse need not be true. Okay, this is our first statement. Right? Now, the second statement. What is the second statement? Every complete graph is a simple graph. वो तो definition में ही दिया है. The graph should be a simple, but converse may not be true. मतलब कोई भी एक सपोज सिंपल ग्राफ ले लो, एक रेक्टेंगल लिया हमने, ये सिंपल हो गया, बट ये कंप्लीट है क्या? नहीं, बिकॉज एवरी पेयर इज नॉट एडजेसेंट हियर. सो दैट्स व्हाई एवरी कंप्लीट ग्राफ इज ए सिंपल बट कॉन्वर्स नीड नॉट बी ट्रू. मतलब उसका उल्टा जरूरी नहीं कि ट्रू भी हो जाए. ठीक है, ये सेकंड स्टेटमेंट हो गया. देन ये तो ऑलरेडी मैंने आपको डेफिनेशन में बताया. सो कंप्लीट ग्राफ विथ n vertices is denoted by kn, कैपिटल K सफिक्स n, kn से डिनोट करते हैं. जस्ट लाइक यहाँ पे हमने K5 डिनोट किया. K5 मतलब कंप्लीट ग्राफ विद द 5 वर्टाइसेस, K6 मतलब कंप्लीट ग्राफ विद द 6 वर्टाइसेस, K3 मतलब कंप्लीट ग्राफ विद 3 वर्टाइसेस एंड सो ऑन. देन नेक्स्ट वन इज व्हाट? एवरी कंप्लीट ग्राफ विथ n vertices has n into n minus 1 upon 2 edges. Every complete graph with n vertices has n into n minus 1 upon 2 edges. मतलब n मतलब number of vertices हो गए. So see, n into n minus 1 upon 2 edges. तो K1 में n कितना है? n is equal to 1. So what is our formula? n into n minus 1 upon 2. So check it. n मतलब 1. 1 into 1 minus 1, that is 0. So 0 into 1, it is 0. And 0 divided by anything is equal to 0. So number of edges कितने हैं? K1 में 0 edges are there. 0. Means no edges there. Okay. Similarly, K2 में अगर calculate करना है, तो n is equal to 2. See, I'll calculate it here. n is equal to 2. 2 into 2 minus 1 divided by 2. How much? So this 2 is cancelled and 2 minus 1 is equal to 1. So there is only one edge in K2. See, दिस इज ओनली वन एज. K3 अगर हम K3 लेते तो नंबर ऑफ एजेस कितने होने चाहिए? K3 में 3 एजेस है. So let's check that formula. 3 into 3 minus 1 divided by 2. So 3 into 3 minus 1 is 2 divided by 2. So 2 cancelled. How much is left here? 3. So there are the 3 number of edges in K3. Okay. So that means by using this
Sir,
formula,
divided by 3.
divided by 2, not 3. See, what is the formula? N into n minus 1 divided by 2. Always divided by 2. Whatever the number of vertices, always divided by 2. Okay.
सर K6 से कैसे ना?
K6. See there. K4 का देखते हैं हम पहले. 4 into 4 minus 1 divided by 2. कितना आता है? 2 1 2, 2 2 4. So 2 into 4 minus 1 is 3. So 2 3 are 6. So there are 6 pages. See there. 3, 4, 5 and 6. 6 number of pages are there. Right? अगर K5 हमें लेना है, K5 में क्या आएगा? 5 into 5 minus 1. I'll write it here directly. 4 divided by 2. So 2 1 are 2, 2 2 are 4. So 5 2 are 10. 10 number of edges should be there in the K5. See, 1, 2, 3, 4, 5. ये जो edge है 6. This one is the 7. This is the 8. This one is 9. इसको नहीं दे सकते because already it is given the name. And this one is 10. बाकी सारे edges को हमने नाम दे दिया है. So there are 10 number of edges. अभी इसमें कितने देखो? K6 में according to the formula, how many number of edges should be there in K6? 6 into 5, that means 6 minus 1 divided by 2. So 2 1 are 2, 2 3 are 6, and 5 3 are 15. So there should be 15 edges in the K6. K6 में 15 edges होने चाहिए. Check it. 1, 2, 3, 4, 5, 6. ये एक एज हो गई 7. ये सेकेंड 8, 9. दिस शुड बी 10. ठीक है. तो बीच के दो डायगोनल्स 11 एंड ये 12. देन ऊपर की एक 13, ये वाली एक 14 एंड ये वर्टिकल जो है 15. सो देयर आर टोटल 15 एजेस. या फिर मैं आपको ऐसे भी काउंट करके बताता हूँ, डिलीट करके बताता हूँ मैं आपको. सी, एज नंबर 1, ठीक है, डिलीट कर दिया. एज नंबर 2, एज नंबर 3, एज नंबर 4, 5, 6, ठीक है. 7 कहाँ पे है? ये वाली, इसको हमने 7 बोला था, सॉरी. ठीक है. 8, ये बीच वाली 8 होगी, ये वाली. 9, ये 9 होगी. 10, दिस इज 10. 11, ये 11 होगी. राइट. 12, दिस इज 12. 13, 14 एंड 15. ठीक है. सारे एजेस गए. सो दैट मीन्स देयर आर द टोटल 15 नंबर ऑफ एजेस. ठीक है. मैं वापस एक बार ड्रॉ कर देता हूं. सॉरी. 1, 2, 3, 4, 5. Then 6, 7, 8, 9, 10, 11, 12, 13, 14 and 15. So there are total 15 number of edges. Clear? So if you have a complete graph and number of vertices of the complete graph, then easily you can find out the number of edges by using this formula. ये फॉर्मूले से आप डायरेक्टली कैलकुलेट कर सकते हो. Okay. Now one more thing is here. I'll add one more note here. Fifth note. So every complete graph with n vertices. Every complete graph with n vertices has how many number of edges? अगर n vertices complete graph है तो number of edges कितने होते हैं? Sorry, what is the degree of each vertex?
n minus 1.
N minus 1, exactly. Okay, so every complete graph with n vertices has degree n minus 1. ठीक है, ये एक एडिशनल नोट होगी. मतलब अगर n vertices complete ग्राफ है तो उसमें हर एक वर्टेक्स की डिग्री क्या होगी? माइनस 1 होगी. मतलब इट इज अ कंप्लीट ग्राफ विद द 6 वर्टिसेस K6. तो K6 में हर एक वर्टेक्स की डिग्री क्या होगी? 5 होगी. Okay, so like that we can find out the degree of each vertex. So that is the complete graph, the third type of the